In this video, I will show an overview of the entire project. Because I have 5 ESP8266 IoT devices, I decided to write 5 different Arduino programs. Each program is associated to one of the ESPs, and I load the related program to the corresponding ESP. For example, here I have the program for the ESP number 2. So this is the program that I'm loading in the ESP number 2. So I've already loaded all these files, all these codes in the corresponding IoT devices, and here I'm monitoring the information that is being transferred from the GUI to the different pins depending on the subdivisions that I showed and explained in my report. So at the GUI level, this is the processing program that allows to run the GUI. So at this point, I have one scenario already implemented, but based on this scenario, the user can already create several events in the experimental setup. So if, for example, I choose scenario 1, it starts with a predefined state where I have the generators of both lines taking care of some specific loads. Here 3 of the loads, and here I have also the circuit breakers on these lines that are on, and it's the same thing on this side. If, for example, I decide to monitor this line here, we will take the serial monitor provided by the Arduino IDE. It will just help us see how the values are arriving at the ESP level. We can see here, for example, that the circuit breakers are set to 1. The loads, which has a random value that varies, is here, for example, set to 23. Here the circuit breaker is set to 1. Let's say something happens and then the generator 1 in this electrical line here goes off. So all the loads are not powered anymore. So we can see that the states of these elements have all changed. We have now 0 arriving at so the load is still there, but the load is not powered. So all the circuit breakers are set to 0s, but the load in terms of demand is still there. So I can decide to turn the generator back on, and I can decide to isolate everything, turn it back on again, isolate only here, power it again. I can come here and isolate this line here, or isolate this line here also, and the user can just play with the elements, and the system will act accordingly. So the information here at the GUI level are being sent to the public MQTT broker, and the ESPs on the hardware level are subscribing to the topic. So here are the specific topics. Subscribing to the topics, gathering the values, and converting the values from string to integers, from integers to binaries, and then writing to the different associated pins. And I can decide to just reset everything. and we see when everything is reset, nothing happens anymore, no more information is being sent, so everything is kind of shut down. Everything that's been recorded is saved in a file. So this is a CSV file that records all the events. So here, for example, I have the number of the event and then the state of the element when that event was recorded. So for future work, I really want to check the timestamp that this IDE here is recording the event, if it corresponds to the same timestamps that the IoT devices are subscribing and getting the information, or if there is a delay, how can this delay be measured, and how can we also check if the system is in some sense deterministic. So next I will just try to monitor using some debugging LEDs the behavior of the loads. We saw here that the loads, which has a random value, changes all the time. So because these values here are converted in binaries, I just went and connected some LEDs to the pins associated to each of the values, and we can see how the LEDs are turning on and off depending on the value that they receive. So this was a way I was able to debug the digital outputs at the hardware level. Because I didn't have a multimeter or an oscilloscope, I couldn't check the digital to analog conversion, check the voltages that I was getting at the end of the DAC conversion, and also check the analog output directly of the ESP. At the hardware level, the system is made of 5 ESP8266, and based on the simulation we showed on the GUI, the elements are encoded either in digital in 1 bit, 6 bit or 5 bits digital values, and we write the values accordingly depending on the subdivision that we chose. So we use the analog outputs of the ESP8266. We also use the digital outputs, and here we have two implementation of R2R layers for DAC conversion, because we have some loads that we encoded in 6 bits values, and here we have one implementation of R2R layers for a 5-bit input. And here we already have the wires. So for example, if we want to debug a value, we can just go to the specific pins depending on the subdivision and then get the output. So this is an example. Here we have the debugging LEDs. This is the LEDs that were used to make sure that the values that were sent into the ESPs were exactly the one that we got from at the GUI level. So here I have 6 LEDs that allowed to debug 6 bits inputs and also 5 bits inputs. For example, here I'm monitoring the loads that changes when the system is running. So you can see the alerts turning on and off. Here it just means that the bits here is 0, and when it turns on, the bit is 1, and so this translates to the values, the binary values of the loads when the system is running. So this experimental setup can be expanded with more DAC implementation with wires directly connected to the output, so every time the user doesn't have to go and connect, connect, remove, depending on which values the user wants to record.